Right, Assalamualaikum warahmatullahi wabarakatuh. My name is Fadil Sarifi, with student number 2034-32043. And now I will explain to you about my practical report in machine learning lecture. It is about neural network and key learning. So the first one is the neural network code. So as usual, import the library first. So in here, we're using or we call or we are import pandas, numpy, matplotlib, pyplot, seaborn collections, label encoder, and standard scalar. Pandas spd, numpy snp, and pyplot splt, seaborn ssns, and label encoder and standard scalar. So the next one, or the next cell is we call the or load dataset or the save the dataset to the variable which is the name is dataset. So dataset equal PD, we calling the read CSV function in pandas, and with the parameter is the name of the or the title of the dataset file. So this is we are using the game CSV here, and for brief, game CSV is about chess games dataset, and this is the dataset head. Here is the first or the first five row in the dataset. So this is the ID rated the columns we can see here, and the next one cell is preprocessing and feature selection. So we only need some feature. So we drop or we don't use some others like ID created 8, last move 8, white ID, black ID, moves, opening name, and save to the drop calls columns variable. So it is saved to df clean dataset drop columns equal dot calls, which is this is. So it will drop or delete the column ID created at and all of this until opening name. And this is the we will encoding the categorical feature to numerical feature. So we Victor or declaration LA dic, which is the this is the dictionary. So the cat calls or the category columns is rated victory status increment code opening echo. We will change this or change the from categorical to numerical. So it is the looping. So for call in cat calls. So along in the cat calls, which is the 1, 2, 3, 4, it will looping until 4 times. So LE equal label encoder, we save or we add the label encoder to LE variables, and the F clean call, it is the fit transform, and this is the LA target for label encoder. We fit transform again to the Y, which is the this is the winner column, which is the it is our Y variable, and this is the to separate the data from X and Y. X feature X and Y is target. X row for the X feature, the independent variables. And this is the before we get into the train test split or splitting the data, we need to scalar it first using standard scalar and save it to the scalar variable name scalar. So x equals scalar we transform with the parameter x row. We can see here the dimension of data. So it is among 2000 row and 8 columns. You can see so many data here. So the next one is the collections. And the next cell is splitting the data from testing and the training with the ratio 3 point 0.3 for the test size. So like it is like 30% for the training for the testing data, and the other is around 70% is for the training with the random stat is zero. After we splitting the data, after splitting the data, uh, we import the MLP classifier from a scalar neural network. So the variable model, is saving MLP classifier with this parameter. So hidden layer size is 150, 150. So max iter is around 450. Random state is 1. And this is the model fit with the parameter x train and y train. And this is the for evaluation score. So we import the accuracy score from Escalon matrix, and ypred is saving the model predict with parameter x train. So so the result from the model predict, it will be saved in ypred variable, and ypred test for the x test data. And this is the accuracy we can see here. Training data accuracy is 86%, and the testing data is just 62%. It's not too bad, but it's not too good. And the next is we have to one sample data. So it is just we random from the data, we take one sample, and this is the prediction. So the class is 2, and the label winning is white. And this is for the grid search. So in case the neural network has so many parameters, so we can find the best for our model. So activation is identity, logistic, time value, save in the activation dictionary. And for solver is LBFGS, SGD, ADAM, and learning rate constant in scaling, adaptive. For the random stat is 1. So we call the grid search CV, save to the grid search variable, and fit the X train and Y train. And this is the accuracy score, or the best score from grid search, our grid source parameter. So the next one is key learning as well. Import the library first. This is the for the configuration or declaration the grid or labyrinth. So n states is 16. So it will 4 times by 4 matrix. So the goal state is 15, and the start state is 0. So it is start from 0 index. And and I add some X obstacle here in 5 and 10 index, the obstacle. And this is the Q table first. This is the declaration learning rate, discount factor, and epochs. Learning rates is 0.8 and discount factor 0.95 and epochs is 1000. Epochs is for the looping. It will loop until 1000 times to get the best way from the start state to the goal state. This is the epsilon, and this is for the rules. And if action 0 and it is for to the top, to the bottom, to the left, and to the right. This is the reward system, and this is for looping to the until from the start state until the goal state. And this is for the visualization. You can see here. This is the value in the or the key value. So we use the cool warm. So goal in the nearest the goal it will be warm or the color will be more and the value is high from the start. Okay, maybe only I can explain to you guys. Wassalamualaikum warahmatullahi wabarakatuh.